Hi everyone, today we're going to look at a leetcode problem called the longest arithmetic subsequence of given difference. Given an integer array and an integer difference, return the length of the longest subsequence in array, which is an arithmetic sequence such that the difference between adjacent elements in the subsequence equals difference. And let's look at some examples. Suppose the array is 1, 2, 3, 4, the difference is 1. We can see that 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1. So the longest arithmetic subsequence is the array itself, and we output 4, which is the length of the array. Now let's look at the second example. The array is 1, 3, 5, 7. The difference is 1. In this case, the longest arithmetic subsequence is any single element. It could be 1, could be 3, could be 5, could be 7. In other words, you can't find any arithmetic subsequence with a length greater than 1 that has a difference of 1. You can solve the problem in multiple ways. One of them would be brute force. In this method, you get each subsequence of the array by choosing to keep or drop each number. And when you get each subsequence, you check if it's an arithmetic sequence with the required difference. For example, suppose the array is 1, 2. And you have 4 choices. First, you can choose to keep 1 and keep 2. In this case, you get 1, 2. The second choice, you can choose to keep 1 and drop 2. In this case, the answer is 1. The third choice, you can choose to drop 1 and keep 2. And the subsequence in this case would be 2. The fourth case, you can choose to drop 1 and 2, and you get nothing for this choice. So we don't need to consider the last choice. As you can see, all the subsequences are 1, 2, 1, and 2. And after obtaining all the subsequences, you need to check them one by one to see if it is the required subsequence. So as you can see, the time complexity would be pretty high. First, you need to get all the subsequences. The time complexity for this step would be 2 raised to the power of n. And after getting all the subsequences, you need to check each subsequence one by one. And the time complexity for checking each subsequence would be O of n. So the final time complexity would be this. And you can see that the time complexity would be way too high, and you will get a time limit exceeded if you use this method. So, is there any way to solve this problem more efficiently? First, you need to realize that each number in the array must be in at least one arithmetic subsequence with the required difference, even if the subsequence length is 1. So we can iterate through the array and find the length of the longest required subsequence ending with the current number. Let's call the length map n. And let me repeat. Map n is the length of the longest required subsequence ending with the current number. Also notice that when calculating map n, you don't need to consider the following numbers after n. Take 1, 3, 5, 2, 3 as an example. You need to calculate map 1, map 3, map 5, map 2, and another map 3. When calculating the second number, map 3, the corresponding subsequence must be obtained from the first two numbers. Because we only saw the two numbers for now, you don't need to use any numbers after the second number, even if we have another 3 in the end. In this way, you might have noticed that we need to calculate two map 3s in the whole iteration. Map 3 for the second number and map 3 for the last number. Map 3 for the second number might have a different value from map 3 for the last number. And when we calculate map 3 for the last number, it will override map 3 for the second number because all of them store in map 3. That is okay because map 3 for the last number must be equal to or greater than map 3 for the second number. Remember that we're searching for the longest subsequence, so using the later map 3 is fine. So think about it. If we can calculate map n for each number n in the array, then the answer must be innate. It should be the maximum of them. So our answer should be the maximum of map n. But how to calculate map n? Let's take array 1, 3, 4, 5 as an example. And the difference d equals 2. And let's go through the process. Since we're going to iterate through the array, so the first number will be 1. What's map 1? Map 1 is 1 because we only have one number for now in map. Notice that we don't need to consider following numbers. And the second number, 3. What's map 3? Map 3 is 2 because the corresponding subsequence is 1, 3. It satisfies the requirements. And the ending number is 3. Also notice that map 3 is equal to map 1 plus 1 because they are in the same subsequence. The subsequence for map 1 is 1. The subsequence for map 3 is 1, 3. So map 3 is equal to map 1 plus 1. And for the third number, map 4, what's its value? Its value would be 1, and the corresponding subsequence would be 4. It doesn't have a previous number. The whole subsequence only has one number 4. The fourth number, 5. What's 5? What's map 5? Map 5 equals 3. And the corresponding subsequence is 1, 3, 5. And also notice that map 5 equals map 3 plus 1 because the subsequence ending with 5 includes the subsequence ending with 3. And 5 is the next number following this subsequence. So map 5 equals map 3 plus 1. I don't know if you have noticed or not. The value of map n depends on the value of map n minus d, where d is the difference and n minus d could be the previous value of n in the same subsequence. So what's the relationship of them? There are two cases we need to consider. The first case, if map n minus d exists, then n could be the next number of n minus d subsequence, which means that map n is equal to map n minus d plus 1. We can see that from our previous example. Map 5 equals map 3 plus 1, and map 3 equals map 1 plus 1. That is the first rule. And the second rule, if map n minus d doesn't exist, then map n should be 1 because there are only one number in the subsequence for now. And the time complexity of this method should be O of n because we only need to iterate through the array once. And in this iteration, we calculate map n for each number n, and in the end, we just calculate max map n to get the final answer. So this method would be pretty efficient. Now we know how to solve this problem. Let's code. First, let's define a map. The map is what we have illustrated before in here. It's map n. So the key of the map is n, which is each number in the array, and the value of the map denotes the length of the longest required subsequence ending with the current number. And after defining map, we need to iterate through the array. And for each current number, we need to find its possibly previous number, which is the current number minus difference. And we need to check if the previous number exists or not. If it exists, we can consider num and the previous num are in the same subsequence. They can be placed in the same subsequence. So in this case, we can say that the value of the current number should be the value of its previous number plus 1, which is our rule 1. And if the map doesn't contain previous number, we can see that the value of the previous number should be 1, which corresponds to rule 2 in our previous illustration. And in the end, we need to return the maximum value in map. So let's define the result and initialize its value to the minimum value of the integer. And then we iterate through all the value in map and update the results along the way. And we return it in the end. As you can see, the solution is pretty efficient, and that's all for the current problem. If you think this video is helpful, please hit the like button and subscribe to it. Thank you for watching.